Hi everybody, this video is going to talk about zeros and multiplicity for polynomial functions. So the fundamental theorem of algebra, okay, something you'll learn about in future classes in more detail, says that any polynomial function of a degree n has n number of roots. Okay, it might include complex roots, that have some imaginary numbers involved. And it also counts something called multiplicity. So the idea is, if I have a function, let's say x squared, because this function has a degree of 2, I should have 2 roots. Remember, roots are the same as zeros, x-intercepts, solutions. Okay, those words are all talking about really the same thing in the context of not only quadratics that we've previously talked about, but also these polynomial functions. So let's consider this function x cubed minus 3x minus 2. Okay? The fundamental theorem of algebra tells me that because I have a polynomial with a degree of 3, there should be 3 roots. However, graphically, there only appears to be 2. It looks like I have one at x equals -1 and at x equals +2. So here's the catch. If I were to take this function and factor it, I would see that there are 3 factors, x plus 1 times x plus 1 times x minus 2. We know that when we're solving for zeros, we can take each of these factors and individually set them equal to 0. So let's see what happens there. Here, when I set x plus 1 equal to 0 and solve, I get x equals -1. Okay? Since I have a repeat, a duplicate of that factor, again, I'm going to get another 0 of -1. Here, I'm going to get an x value, okay, a 0 at 2, which again is where we saw those zeros appearing on our graph, at -1 and at +2. So the reason that we only see 2 graphically is because we get duplicate factors which result in 2 of the same 0. This is what we call multiplicity. If I have this factor of x plus 1 appearing twice in the factored form of my polynomial, I'm going to have the 0 from that factor twice, meaning x minus 1 has a multiplicity of 2. X equals 2 would have a multiplicity of 1 because there is only one of those solutions. There is only one factor that corresponds to that solution. So multiplicity is really talking about duplicate factors that result in duplicate zeros, roots, solutions, x-intercepts. Okay, so let's talk about the effect that that has on the graph. Okay, in general, if we have a 0 that has an odd multiplicity, the graph is going to cross at that 0. If we have a 0 that has an even multiplicity, then the graph will bounce at that 0. So let's backtrack here. Okay. We said x equals -1 has a multiplicity of 2. So we can see that at this 0, our function comes up, it hits the x-axis, and it turns right back around. So we're going to call that, we're going to describe that as bouncing. Okay? It doesn't actually cross over the x-axis to the other side. It hits -1 on the x-axis, and it turns right back around. Okay? So that's what happens when you have an even multiplicity. Okay, but for something like x equals 2 that had a multiplicity of 1, okay, that has an odd multiplicity, so it's going to cross at that 0. Okay, So if it has an odd multiplicity or a multiplicity of 1, it's going to cross at that spot on your x-axis. And if the multiplicity of your 0 is even, it's going to bounce, meaning it hits the x-axis and it turns right back around. All right, guys, so that is it for zeros and multiplicity. In future videos, we will get into more detail about how we can actually solve for zeros by hand with factoring, but that's going to require a little more detail and we'll need to go more in depth. We don't really have time for it in this video. So for right now, I want you to be able to identify zeros graphically and their multiplicities. Have a great day.